Welcome, my dear learners, for this course on control engineering. In this final module, that is in module 5, we are discussing on board plot. So far, we have solved two numerical problems on board plot. Let us continue our discussion. The problem number 3 of our discussion on board plot states that draw the board plot for the transfer function g of s into h of s is equal to 4 into 1 plus 0.5s divided by s square of 1 plus 2s into 1 plus 0.05s plus 0.125 square s square. From board plot, determine drain crossover frequency, phase margin, comment on the stability of the system. If we observe the given transfer function, it has constant k whose value is 4, and we have one simple 0 because it is in numerator, and we have s square term, that is 2 poles at origin, and we have one simple pole and we have one complex pole. Come, let us solve this problem. If I observe, already the given problem itself is in standard time constant form. So no need to worry about converting the given transfer function to standard time constant form because the given function itself is in standard time constant form. So moving ahead for solution of this problem, in step 1, we should find the time constant form of the given transfer function, that is time standard time constant form. But he himself has been specified in standard time constant form. If I recall the standard form, we'll get k of 1 plus tas divided by s to the power of n of 1 plus t1s of 1 plus 2 theta omega n s plus omega n, s by omega n, correct? S by omega n whole square. So this is standard time constant form. This you people already know. Where zeta is damping factor or damping ratio. Now comparing with this is yes. Now comparing it with this, already the given function itself is in standard time constant form. So write it as it is. So g of s into h of s will be what? 4 of 1 plus 0.5s divided by s square of 1 plus 2s of 1 plus 0.05s plus 0.125 square s square. Correct? So this is what he has given. Comparing it with standard form, we already have it in standard time constant form. Now move for step 2. What is step 2? Step 2 is discussion of factors. Moving ahead for step 2, that is discussion of factors. So let us discuss the factors present in the transfer function by taking one by one. Let us first take the constant term k. So if we take the first one, that is constant term k is equal to 4. Correct? So given k is equal to 4, what is the magnitude of this? This is the straight line at 0 degrees plotted at a magnitude of 20 log 10 k, that is 20 log 10 4. Hence the inference is that the straight line at of 0 degree at 20 log 10 k. How much is 20 log 10 k? You are going to get. How much is 20 log 10 4? 12.04. So entire board plot will be shifted by a gain margin of 12.04, by a margin of 12.04. Unit will be decibels, correct? Because it is in log scale. Next, move for the second one. Second, I should go for simple poles, poles at origin or zeros at origin. This problem does not contain any zeros at origin. It contains only poles at origin. But if we carefully observe, we have two poles because it has s to the power of 2. So hence, next term is s square. S square term is called as what? Two poles at origin. Two poles at origin. You might get confused. S square is two zeros at origin. But what here given is 1 by s square, right? Let me write it like that only. Or it is s to the power of minus 2. 1 by s square. Two poles at origin. For two poles at origin, we know that it is the straight line of slope. The inference is the straight line of slope. What is the contribution of two poles at origin? It is minus 20 into n. Here minus 20 into 2, it is nothing but minus 40. Correct? General formula is the slope of the poles at origin is nothing but minus 20 into n, where n is the number of poles. Here I have two poles, hence it is minus 20 into 2, which is nothing but minus 40 dB per decade, decibels per decade. Minus 40 decibels per decade. And it does not have any corner frequencies, correct? If I write it in standard time constant form and replace s by j omega and c, I don't get any time or corner frequency. Hence, it is at omega c greater than or equal to 0. Because we don't have any frequency for this. Next, move for the third one. Third one is left to you. Either you can go with simple pole or simple zero. Let me go with simple zero. Simple zero says what? It is 1 plus 0.5 s. 1 plus 0.5 s is what? Simple zero. If I consider the simple zero, it is the straight line of slope. It is the straight line of slope. How much? Minus 20, right? Minus 20 decibels per decade. Minus 20 decibels per decade. Right? How much is frequency? How much is frequency? Calculate time. Time is how much? It is of the form 1 plus ts. Time is 0.5 seconds. And so much is corner frequency? 1 by t. It is 1 by 0.5, which is nothing but 2, right? It is 2 radians per second. Hence, at frequency greater than or equal to 2 radians per second. Next, move for the fourth one. That is, we have simple pole. Simple pole is 1 plus 2s. 1 plus 2s is called as what? Simple pole. For simple pole, let me determine the time constant, which is 2 seconds, and corner frequency will be 1 by t. That is 1 by 2 is 0.5 radians per second. Hence, it is straight line of slope. Straight line of slope minus 20 decibels per decade. Here it is in numerator, right? So therefore it is plus 20. I am extremely sorry. For simple zero, the slope is plus 20. For simple pole, the slope is minus 20. I'm sorry, kindly make the correction. For zero, it is plus 20. For pole, it is minus 20. For simple pole. For simple zero, it should be plus. Very, very important. It should be plus 20. Here it is minus 20. Correct. Similarly, if we would have two zeros, then it is plus 20 into m. It will become plus 40. If it would have been two zeros. But here it is two poles, hence it is minus 40. Next, move for the complex term. If we move for the complex pole, what is that complex pole we have? It should be inverse, right? It is 1 by 1 plus 2s. This is the denominator. 1 by 1 plus 2s, hence it should be inverse. Now if I go for complex pole, it is 1 divided by this term, which can be written as the inverse of that term. That is 1 plus 0.05s plus 0.125 square s square whole to the power of minus 1. Now comparing it with the standard form, find the natural frequency of it. Natural frequency omega n square will become what? 1 by 0.125 square. Correct? Hence, what will be the frequency of this? Frequency of this will be root and square will get cancelled. It is just 1 divided by 0.125, which is nothing but 8 radians per second. So frequency we have got. If you want time period, it is nothing but 1 by t, and also we can find what is the value of zeta. So if I want the value of zeta, what will be the value of zeta? So 2 zeta omega n must be equal to 0.05. Hence the damping factor zeta should be 0.05 divided by 2 times 8, 16. It is 0.00325. 0.00325 is the damping factor. Hence, for complex pole, it is a straight line with slope minus 40, correct? So it is straight line with slope, minus 40 decibels per decade. Minus 40 decibels per decade at omega greater than or equal to 8 radians per second. So hope you followed. So we have done the discussion of all the 5 factors what we have for the given transfer function. Next, if I move for the resultant slope table, if I move ahead for resultant slope table, I will get resultant slope table. It has the factors, frequency range, and resultant slope. Resultant slope of the straight line given in decibels per decade. As I already said, I should consider the factors in the increasing of order of their frequencies. So if I go for K, first term, it does not have anything, right? No frequency range, no slope. It is a straight line of 0 degree. Okay. All are straight lines only. What I mean to say is that it is at 0 degree. It is not an inclined line, so therefore slope will be 0. Next, if I go for next one, if I write it in increasing order of horn frequency, next second term should be this one, and comparing with these two, the frequency is less for 0.5. Therefore, simple pole should come and later simple 0 should be written. Be careful. Don't write simple 0 and then simple pole. You will mess up with the things. So therefore, second term should be s to the power of minus 2, and next I should go for simple pole because its frequency is less than simple 0's frequency. It is 1 plus 2s inverse, and then we have simple 0 as 1 plus 0.5 s, and then we have complex pole, that is 1 plus 0.05 s plus 0.125 s whole square. Now if I complete the table, I'm going to get the frequency range is greater than 0, and here the frequency range is greater than 0.5. Here the frequency range is greater than 2, and here the frequency range is greater than 8. So hence the range will be what? So I written it increasing order of their frequencies. Now it has been arranged properly. Now we replace this. So it is 0 to 0.5, 0.5 to 2, 2 to 8, and then 8 to infinity. Hope you are following. Now what is the contribution of 1 by s square? That is 2 poles origin. It is minus 40. Since we don't have anything in the previous row, the cumulative value remains same as it is minus 40. Now take this minus 40 here. It is minus 40. Contribution will be minus 20. Hence it will be minus 60. Take minus 60 here. Minus 60. Contribution will be plus 20. Minus 60 plus 20 should be how much? Minus 40 again. It is come down. Minus 40. Then we have minus 40. This is also minus 40. So final line will be of a slope minus 80 decibels per decade. Hope you are following. So I completed the magnitude plot requirement. Next move ahead for step number 3, that is phase angle. Step number 3, that is phase angle calculation. For phase angle plot, replace s by j omega. Replace s by j omega to get the equation for phase angle. So if I replace s by j omega, then get g of j omega, h of j omega is equal to 4 into 1 plus j times 0.5 omega whole divided by s square is j omega square into 1 plus j times 2 omega into 1 plus 0.05 j omega plus 0.25 square j square. It will become minus j is minus j square is minus 1, hence it will become minus 0.125 square omega square. 0.125 square omega square. Correct? J square is minus 1. So hence I can write the phase angle plot phi as, here the constant is 0 degree. No worries. Here I have simple 0 tan inverse, therefore it is plus tan inverse of imaginary part is 0.5 omega and real part is 1. No worries. So if I come here, I have s square term. What is the contribution of s square term for phase angle plot? It is 1 by s square. That is simple pole. For simple poles, the contribution for phase angle plot is minus 90 into n. Here n is 2. So therefore it is minus 90 into 2. Minus 90 into 2 is minus 180. Let me write this first. Since it is a constant value, let me write that as first. It is minus 180. Minus 180 degree plus tan inverse of 0.5 omega. Next, go for simple pole. It is minus tan inverse of 2 omega minus tan inverse of imaginary part by real part. Imaginary part is 0.05 omega 0.05 omega, where the real part is 1 minus 0.125 omega square. Correct? Imaginary part by real part. So hence we got the equation for phi. Now if I plot variation of phi with reference to omega until I should find the value of minus 180 degree. That is, the phase crossover frequency is the frequency at which the phase angle is equal to minus 180 degree. If you carefully observe, the phase angle is starting from minus 180 degree, which means that if I put omega is equal to 0, tan inverse of 0 is how much? 0. So this will become 0, this will become 0, and this will become 0. Hence, at omega is equal to 0, I will get the phase angle as minus 180 degree. But anyhow, I should consider the sketch, right? So therefore, I should take some values and plot. Let me take some values and plot. That is, I will take as 0.1, 0.2, 0.5. Then I will take 1, 2, 3, 5, 10, 20, 50, and 100. So for which you fill up the table. If I fill up the table, I will get, for 100 it is 179. So I have tabulated from 0 to 100, and above 100 if I observe, it is remaining, the phase angle is remaining to be constant at 179. So if it move at 179 degree for up to 10 to the power of 5, I computed for 10 to the power of 5, but I have not written here. You can also check till 10 to the power of 5. If you go, it will be remaining at minus 179. So I tabulated from 0 to 100. Hence, the crossover frequency is occurring at the frequency of 0 degree, when which we get phase crossover frequency. So phase crossover frequency for this problem is 0 degree, and corresponding gain margin is what I should get from the board plot. If I am unable to get from the board plot, I can go for the definition of gain margin. Definition of gain margin is nothing but what? It is inverse of magnitude evaluated at phase crossover frequency. That is minus 20 log 10 magnitude evaluated at omega is equal to 0. So I should determine what is the magnitude of the given function and find out what is the value of minus 20 log 10 of this magnitude, which is evaluated at 0 radians per second. That will give us the gain margin. So we have obtained the phase angles to plot, and also we have obtained the resultant plot, the slopes of the straight line. So if I put it in board plot, I can determine at what frequency the magnitude plot is crossing 0 reference line. That will give us gain crossover frequency. So the frequency at which the magnitude plot attains the magnitude of 0 decibels. Let me plot the magnitude plot for the resultant slopes what I have obtained and check at what frequency this is crossing 0 decibels line. That will give us the gain crossover frequency, for which I can calculate what is the phase margin. And phase crossover frequency is at 0 radians per second, for which I should determine gain margin, so that I can comment on stability of the given system. So come, let us go for board plot.
Now moving ahead for step number 4, wherein which I want to plot bode attenuation curve. So this is the problem what we had, correct? So for this problem we have already determined the magnitude plot, that is resultant slope table, as well as the phase angle plot table, correct? Now if you carefully observe, the maximum slope that I require is minus 80 decibels per decade. Minus 80 decibels per decade is the maximum slope I require to plot the bode attenuation curve. So therefore, for this problem, I want minus 80 decibels per decade as the maximum slope. Hence, I'll start marking from plus 80. as you already know, using positive values I can generate negative slopes. Using negative values I can generate positive slopes. Hence start from 80 decibels, 40 decibels, and then 80, 60, 40, then 20, and then 0 decibels. So similarly, I don't want any positive slopes, but let me use minus 20 and minus 40 for completion purpose. And next, coming for angle plot, if you observe, the angle itself starts from minus 180 till minus 218. So after that it again decreasing, so therefore I will stop at this point. So the phase angle plot is starting from minus 180 degree and then it is reaching minus 218. So therefore what I will do, I will start the phase angle plot from minus 180 degree itself, because for 0 radians per second I am getting the phase angle as minus 180 degree. So for 0.01 or for 0.1 I am getting minus 189 degrees. So for 0.1 I am getting minus 189 degrees. Hence I will start from minus 180, increasing which I will get minus 210, and then I will get minus 240, and then I will get minus 270. So I am taking each unit as 30 degrees for phase angle plot. Keep that in mind. And next, adding 30 for it, I will get minus 300. Clear? So since the problem is starting from minus 180 degree and it is increasing to minus 218, so start the phase angle from minus 180 degree itself. Now for magnitude plot, we know that 0 decibels is the reference, so therefore mark 0 decibels as the reference for magnitude plot. I am marking it. Take 0 decibels as a reference for magnitude plot, and minus 180 degree is the reference for phase angle plot. This you people already know. Take minus 180 degree as the reference for phase angle plot. I have taken. Now from here till here I am using this as phase angle in degrees. I am using this as phase angle in degrees. Phase angle in degrees, and from the beginning till this point I am using this as magnitude in decibels. Magnitude in decibels. Keep that in mind. Now if you carefully observe the problem, I require minus 180 decibels per decade as a maximum slope. As we already know, the minus 20 decibels per decade line will intersect the 0 decibels at 1 radians per second, correct? So since if you observe the frequencies are 0.5, 2, 8 and infinity. So therefore I can start from 0.1. If in case the corner frequency is less than 0.1, then what I should do? I should start the graph from 0.01. But for us the frequency is more than 0.1, so therefore I can start from 0.1 as usual. So start from 0.1 into 10 is 1, that is 10 to the power of 0. 1 into 10 is 10, that is 10 to the power of 1. 10 into 10 is 100, that is 10 square. Then we have 10 cube and 10 to the power of 4. So these are frequencies in radians per second. Frequency in radian per second. Now generate these slopes. How to generate these slopes you people already learned, as you people already solved 2 problems on board plot. So join from plus 20 decibels to 0 dB at 1 radians per second. So this is 1 radians per second and this is 0 decibels. So generate the slopes. I am generating the slopes. from 20 decibels I am joining it to 0 decibel at 1 radian per second. Similarly, from 40 you connect 0 decibels at 1 radian per second. Similarly, from 60 you connect 0 decibels at 1 radians per second. Similarly, from 80 you connect 0 decibels at 1 radian per second. So these will give you, this is what, minus 80 decibels per decade, and this is minus 60 decibels per decade, and this is minus 40 decibels per decade, and this is minus 20 decibels per decade. Correct? Now, to start the problem, we have the value k here for this problem. So therefore, I want the shift. What is the shift? Since the value of k is 4, the shift for the magnitude plot is 20 log 10k. That is 20 log 10 of 4. So if I calculate for 20 log 10k, 20 into log 4, the shift is turning out to be plus 12 decibels. Plus 12 decibels. The shift measured above 0 decibels is positive shift. The shift measured below 0 decibels is negative shift, right? So therefore plus 12 decibels means I should move upward, plus 12. You can see here 0, plus 20, plus 40, plus 60, plus 80. I am getting plus 12. So therefore I should move upward. Now for 5 lines I have 20 decibels. Therefore how much is for one line? One line is how much? That is 4 decibels. This also you people already know. The value of this is 4 decibels, correct? 4 decibels. Similarly for angle, the value of one line is 6 degrees. 6 degrees. Because each unit I am taking it as 30 degree. The 30 degrees for 5 lines. So therefore one line is equivalent to 6 degrees. Now I want the shift to start the problem. The shift is 12 decibels. So each line is 4. Hence I should move 3 lines upwards. That is 12. 4, 8, 12. So shift is obtained for us. So therefore make a shift of 12 decibels. I am making the shift. Let me use dashed lines to differentiate between reference and the shift. So this is the shift I am getting. That is plus 12 decibels to it. If we don't know the value of k, then the shift will not be coming to picture. The problems which involves calculation of k does not contain this shift, because we should calculate how much is the shift required for the given gain crossover frequency and equate 20 log 10k is equal to gain margin and then find the value of k. That is for problems which involve calculation of k. But for this problem he himself has been given the value of k. That is for the shift of 4, that is for the shift of 12 decibels, I am determining whether the system is stable or unstable. So since we have the shift, the very first line what I have is minus 40. You can see here. The very first line what I have is minus 40 decibels per decade. That is for 2 poles at origin. So hence I should do minus 40 decibels per decade. So offset the minus 40 decibels per decade. This is minus 40 decibels per decade. That is the starting line for me. You observed. Now this should be shifted to the 12 decibels. So I am using roller scale for better accuracy. You people also use roller scale to avoid errors. So now shift this to the 12 decibels at 1 radians per second. So I shifted. Now I got the starting line. Correct? So this line is minus 40 decibels per decade, which I got after shifting to plus 12 decibels. But here the frequency varies from 0 radians per second to 0.5 radians per second. this is 1 radians per second, therefore I cannot connect directly the shift to from 0 to 1 radians per second, that is minus 40 decibels per decade line. I cannot connect to the shift, because if I connect here it will reach 1 radians per second, but the condition what we have is minus 40 decibels per decade varies from 0 to 0.5. Where is 0.5? This is 0.1, 0.2, 0.3, 0.4, 0.5, that is still here. So I should stop at this point. So stop at this point, 0.5, done. That is make a shift, done, shifted. The first line, very first line is minus 40 decibels per decade, shifted. Don't draw the line, because the minus 40 decibels per decade is varying from 0 to 0.5 radians per second. If I draw a line, then it will become 1 radian per second. So therefore, in order to stop it at 0.5 radians per second, I stopped here itself. Now what is the next line? Next line is minus 60 decibels per decade, varying from 0.5 to 2 radians per second. Now you complete the magnitude plot. Take parallel to minus 60 decibels per decade. So this is minus 60 decibels per decade line. Minus 60 decibels per decade line, for which I will take a parallel taken from 0.5, that is end of minus 40. From 0.5 I should draw till 2. This is 1, this is 2. So till here, correct, draw. Next we have minus 40 from 2 to 8. Again you take minus 40 again. So take on minus 40 again. That should vary from 2 to 8. It is already coinciding here, no need to worry. So just you extend it from 2 to 8. This is 3, 4, 5, 6, 7, 8 till here. So extend till 8, done. Next I have minus 80 decibels per decade. So this is minus 80 decibels per decade, that is from 8 to infinity. So draw a line parallel to minus 80 decibels per decade from 8 radians per second to infinity. From 8 radians per second till infinity. So let me stop here. So this is very first one is minus 40 decibels per decade, that is after offset to 12 decibels. Why? Because this offset is equal to 20 log 10 of k. K is 4 for this problem, hence I got plus 12 decibels, that is the offset. From 0 to 0.5 radians per second. From 0.5 radians per second to 2 radians per second, it is minus 60 decibels per decade. And from 2 to 8 radians per second, again it is minus 40 decibels per decade. And from 8 to infinity, it is minus 80 decibels per decade. So this is nothing but minus 80 decibels per decade. So we have completed the magnitude plot. Now coming for phase angle plot. At 0 it is minus 180. Now at 0.1, so this is not required. Now at 0.1 it is minus 189. At 0.2 it is minus 197. At 0.5 it is minus 212. So this is also not required. So I have the values. Now mark it. At 0 it is minus 180. This graph does not contain 0 radians per second, right? Now let me show you only phase angle plot. So here we have frequency in radians per second, and here we have angles starting from minus 180. Let me put it this way so that the plotting will become easier for us. Now start from point 1. Point 1 minus 189. Each line is 6. So therefore it is 186. Half of it is 189 at point 1. Next at point 2, 197. So this is point 2. So at point 2, correct. So this is point 2. At point 2 it is 197. That is 186, 192, 198. Let me put it here. Next at point 5 it is minus 212. Which is 0.5? This is 0.5 line. So at 0.5 I have minus 212. This is 210. and bit above that. And next for 1 it is minus 221. At 1 it is minus 221. This is 1 radians per second. It is minus 221, 210, 216, 216 plus 6 is 222. So here I will get. Next for 2 radians per second it is minus 217. So again it will move up like this. And then for 3 it is 214, again bit up somewhere here. And for 5 it is 218. This is 5, so this is 5. For 5 it is minus 218, 210, 216, 218. Somewhere here I will get. So let me have few more points. Let me see for 6 what I will get. For 6 I am going to get minus 180 plus shift tan inverse of 0.5 into 6 minus shift tan inverse of 2 into 6 minus shift tan inverse of 0.05 into 6 divided by 1 minus 0.125 into 6 whole square. For 6 radians per second I am getting minus 228. Let me check for 7 also. If I check for 7, how much I am going to get? Let me put it to 7. For 7, I am getting minus 248. Minus 248. For 8, for 8 I am getting mathematical error, so therefore I will stop at 7. Now we have marked for 5. Then for 6 I am getting 228. It is 216 222. Then I will get 228. Then for 7 also I got. For 7 I am getting minus 248, minus 240, minus 246, 248. At 8 I am getting mathematical error, so therefore I will stop at this point. Now you draw smooth curve like this. You draw smooth curve like this. So this will give you the phase angle plot. So I have got both magnitude plot as well as phase angle plot. Both are done. Right. So this is magnitude plot and this is phase angle plot. Now what is the gain crossover frequency? Gain crossover frequency is the frequency at which the magnitude plot crosses 0 decibel line. So here the magnitude plot is crossing 0 dB. That is, if you carefully observe, it is exactly 1.2. It is exactly 1.2. So therefore I got the gain crossover frequency as 1.2 radians per second. So this is the gain crossover frequency. That is the frequency at which the magnitude plot is crossing 0 decibels. So from the Bode attenuation curve I got gain crossover frequency as 1.2 radians per second. Now using gain crossover frequency I can measure phase margin, correct? So using gain crossover frequency I can measure phase margin. Phase margin is the distance from minus 180 degree line to the phase angle plot. That is this distance. From here how much is for this one. So this is what I require. So how much is this distance is the question. I am getting 7 lines, correct? So till here This distance is the phase margin. Correct. The distance measured from minus 180 degree line to the phase angle plot. So if you count, you are getting 1, 2, 3, 4, 5, 6, 7 lines. Each line is 6 degree. So therefore how much is for 7 lines? 7 into 6, 42 degrees. But we are measuring below minus 180 degree. So therefore phase margin is negative here. Phase margin is minus 42 degrees, because we know that phase margin measured below minus 180 degree line is negative, above 180 degree line is positive. Gain margin measured below 0 decibels line is positive, above 0 decibels line is negative. That you people already know. Now I got gain crossover frequency, phase margin. What about gain margin and gain phase crossover frequency? We have already observed that I am getting minus 180 degree at 0 radians per second. So therefore phase crossover frequency is 0 radians per second. We know that already. Now what about gain margin? Because here in bode attenuation curve we don't have 0 radians per second at all. Now what is the gain margin is the question for us, correct? For that, let me use the definition. Since I don't have 0 radians per second in the graph, let me use the definition of gain margin. What is gain margin? Gain margin is the reciprocal of magnitude of given problem. That is minus 20 log 10 of magnitude of given problem. What is magnitude of given problem? G of s into h of s. This must be evaluated at what? What I should use? Yes, you are correct. Phase crossover frequency is used to determine gain margin. Gain crossover frequency is used to determine phase margin. This people already know. Now, if you carefully observe the problem, so this is the problem what I have. Correct? That is, if I note down, replacing s by j omega, this is what I have. H of j omega is equal to 4 into 1 plus j times 0.5 omega divided by s square should be written as what? J omega into j omega. Keep that in mind. S square should be written as s into s. S is j omega, s is j omega into 1 plus 2s. 1 plus 2s is how much? 1 plus j into 2 omega into 1. Here if I substitute j omega, j square is minus 1, hence I can write as 1 minus 0.125 omega square plus j times 0.05 omega. So this is what I will get. Correct? Now find the magnitude of this and then I can substitute here. So if I first evaluate this at substituting omega is equal to omega pc, which is equal to 0. Now taking the magnitude, what do you mean by magnitude of a plus ib? It is square root of a square plus b square. That is square of real part plus square of imaginary part. Put first omega is equal to 0. So put omega is equal to 0. This will become how much? Magnitude will become 1. Put omega is equal to 0 here. Magnitude will become 1. Put omega is equal to 0 here. Magnitude will become 1. Am I correct? Now this will become 1. Magnitude of this is also 1. Putting omega is equal to 0. I got only real part. That is square root of 1 square is 1. Here also square root of 1 square is 1. Here also square root of 1 square is 1. So what I left out with? I left out with 4 into 1 divided by, here the imaginary part is 0. Omega is 0. What about real part? There is no real part. Therefore it is 0 plus j omega. Put omega is equal to 0. Then this will become 0, right? So it is 0 into 0 into 1 into 1. This is what I got magnitude. Now substitute this magnitude to find the gain margin. So now gain margin will become what? Minus 20 log 10 of 4 by 0. This is what I got. Anything divided by 0 is how much? Infinity. So therefore, how much I got? Gain margin. Gain margin is nothing but minus infinity. This is what I am getting, minus infinity. So gain margin is minus infinity for the phase crossover frequency of 0 radians per second. Hope you followed. So therefore, for this problem, the results what I observed are the results. If I list, first thing I got phase crossover frequency initially itself, which is 0 radians per second, using which we can determine gain margin, which is minus infinity decibels. Next, third one is gain crossover frequency. We found that gain crossover frequency is 1.2 radians per second, using which we have calculated phase margin PM, that is minus 42 degrees. If you observe, both gain margin as well as phase margin are negative, hence the system is absolutely unstable. The system is absolutely unstable. Why it is absolutely unstable? Because both gain margin and phase margin are negative, that too gain margin is minus infinity. So hence the system is unstable. So this is the results for the given problem. What is the given problem? The given problem is here, that is g of s into h of s is equal to g of s into h of s is equal to 4 times 1 plus 0.5 s divided by s square of 1 plus 2s into 1 plus 0.05 s plus 0.125 square s square, 0.125 square s square. So this is the given problem. So for this problem we have drawn bode attenuation curve and found out that the system is absolutely unstable. So finally I forgot to write the scale, right? So let me put the scale for this problem. What is the scale chosen for this problem? We have taken scale only for y-axis, right? For y-axis, for magnitude plot. For magnitude plot, I took 1 unit as 20 decibels, and for phase angle, I took 1 unit as how much? 30 degrees. Correct? 30 degrees. So this is the bode attenuation plot for problem number 3 of our discussion on bode plot, from which we have found out that the system is absolutely unstable with gain margin as minus infinity, phase margin as minus 42 degrees.
So this is the complete solution for problem number 3. That's all from this lecture. Thank you all.